Okay, we're talking about projectiles right now. Now, a projectile is anything launched only under the influence of gravity. So only under the effects of gravity. Nothing else. We're going to ignore air resistance. Although later on at the end we'll discuss how air resistance would change it. But to solve the problems, we're going to have to ignore air resistance, because we have too much factored in if we have to worry about that. So let's take a look at that. So a projectile is anything that's thrown or launched. All of your balls, for all of your different types of sports, things like that. Anything you toss in the air, water balloons, stuff like that. All of those cases are projectiles. Now, key thing to understand is if I have a projectile moving through the air like that, okay, at this point y is equal to 0. That's the ground. And if I take a look at different instances in the flight, it's important that you can differentiate and know some things about it. First of all, the speed in the x direction is constant. So Vx is constant. Now, the reason Vx is constant is there's no acceleration in the x direction, and the x direction equals 0. Again, as soon as I ignore air, I'm not going to change any speed in the x direction. Now, speed in the y direction can change. Here, speed in the y direction is up. It's up here but smaller. Here it's momentarily 0. Here it's down. Here it's down and bigger. So Vy changes due to g. And g we know is negative 10 meters per second squared. Again, 9.8. The negative only indicates the fact that it's going down as we go through it. So it's important to understand that. Now, if I was to look at the sum of those vectors, the sum of those vectors is actually going to be tangent to the path right here. If I was to add those two vectors up, what actually happens is that's my total v. So this becomes vy, this becomes vx, and this is v total. If I do here, that's v total. Here, v total is the same as that. Here, v total is this way, and there, v total is that way. It should be tangent to the path at that particular instant. Now, mathematically, there's two equations we're going to use. V is equal to delta x over t, but that's v in the x direction. And the key thing to understand in the x direction, there's no acceleration in the x direction. Now, the other one we're going to use a lot, we have written it as delta x is equal to vit plus 1/2 at squared. Let me slide it up a little bit. We're going to change it slightly, and I think this helps you to think about it this way. What it really is delta y, because we're talking about what's happening in this direction. So it's equal to VIY times t plus 1/2 gt squared. So that, now, on the AP equation sheet, the formula is going to be closer to this. They're not going to give you this additional formula. Okay, let's look at the two types of problems we can encounter with that. First of all is a cliff problem. The cliff problem is something obviously being thrown off a cliff. Now, key thing in this is they're going to somehow give you the Vx usually. That's usually known. And the other thing they usually tell you is the delta y. They usually tell you the height of the table. So those are the two things we normally know. The key thing is when something flies off the table, it's the same thing we just talked about. The speed in the y direction is going to get bigger until it hits the ground. The speed in the x direction stays constant. So Vx, Vx, and Vx all stays the constant. Greatest speed here, lowest speed at the top. So that's key. Now, let's take a look at it. Let's do a problem. Let's say Vx is 10 meters per second. Let's say we have a car running at 10 meters per second off a cliff. Let's say the cliff is 100 meters tall. That's all you have to be given. Now, the thing you always know is that G is equal to A is equal to 10 meters per second squared down. Now, in a cliff problem, it actually makes sense to call everything positive in the down direction. So now, we're going to use the two equations. I'm going to tell you in projectiles, you're always going to use both equations. So the first thing I have to do, let's make this a goalless problem. What are the things I could solve for? Well, I could solve for the time. I could solve for the delta x, in other words, this distance here until it hits the ground. That would be delta x. I could solve for that. I could also solve for v total at the bottom. Those are all things that we could solve for. There may be other ones, but those are the ones that immediately come to mind. Now, let's solve for t first. Now, the key thing to solving for t, and it may help you to write your unknowns like this. Delta y is equal to 100 meters. Vx is equal to 10 meters per second. A is equal to 10 meters per second squared. And I'm gonna add the word down there. So let's get t first. Now, to get t first, we're going to go to the delta y equation. VIYT plus 1/2 gt squared. But the key thing in a cliff problem is this is 0 because it's a cliff problem. It's not going to be 0 if it's a cannonball problem, which is the next type. Now, here's a helpful thing. You're going to have delta y is equal to 1/2 gt squared. Solve this for t, and you get t is equal to 2 times delta y divided by g, and then the square root of that. This is almost important enough to be an extra equation, because what it does is it gives you the time it takes any object to fall. It doesn't just have to be a cliff problem. It could be something falling straight down. So now let's plug and chug and get an answer. T is equal to 2 times 100 meters divided by 10 meters per second squared. Notice how we leave the units in. We have 200 divided by 10, so it's the square root of 20. You have meters over second squared. That cancels out. It reduces down to second squared, and then when you take the square root of that, you just have seconds on your units. So your units actually do work out. Well, you have a calculator, so you can easily determine what the square root of 20 is. But let's just leave it at that right now. You can solve that. Now, the next thing I want to go is delta x. So Vx is equal to delta x over t. Always do algebra first. Delta x equals Vx times t. So I have the Vx of 10 meters per second times the square root of 20 seconds. Your seconds cancel out, leaving you with meters. So the answer is 10 square roots of 20. You got a calculator, so you can solve that and get a number out of it. Total speed I'm not going to fool with right now. We'll do that at a later date. Now let's do a cannonball problem. Now with a cannonball problem, we have this. What you're almost always going to be given with a cannonball problem is an initial speed, let's say 100 meters per second, and they're going to give you an angle, let's say 30 degrees, like that. Now, what's going to happen in this case is Vx is here. It's this side of the triangle, and that's going to stay the same. Vy, initially, Viy is this side of the triangle. This becomes a right triangle, and this is going to change 10 meters per second squared down. So let's take a look at this. Now, the things I can look for, If we said this is a goalless problem, I could say, okay, what's time? That makes sense. What's the total x? Well, the total x would be this distance here, delta x, how far it goes. That is sometimes called range. That's left over from the artillery days and stuff like that. I could also figure the maximum height, and I'll show you how to do that, although I won't completely calculate that. Now, key thing, step 1 with a cannonball problem. Still going to use the same two equations. Step 1 with a cannonball problem is figure out this. Now, to figure out this, we have to label our, use a little trig. This is the hypotenuse, this is adjacent, and this is opposite. Now, if you do this enough, you will eventually realize that this is adjacent is cosine and opposite is sine. So I'm going to say Vx is equal to V total times the cosine of theta. That's a general equation. And Viy is equal to V times the sine of theta. So those are the two things that we can do. Now, when we go ahead and solve it, we're going to say, this is generic. This is going to work for any cannonball problems. We have 100 meters per second times the cosine of 30 degrees. So it's 100 times 0.866, 86.6 meters per second. That is not going to change. That's going to stay the same. When it hits the ground, this is 86.6. Right here, this is also 86.6. That's not changing. Now, 100 meters per second times the sine of 30 is equal to 50 meters per second. That is going to change. Now, it's going to change by 10 meters per second. Okay, so that's the first step, whether they ask you for that or not. Now, let's figure time in the air. Now, there's two ways to get time in the air. You can actually reason your way through this. If your initial speed is 50 meters per second, and you're losing, your A is equal to 10 meters per second, it's going to take 5 seconds to get to where the speed is 0. So that means it took 5 seconds up. If it takes 5 seconds up, it takes 5 seconds down, 10 seconds. Now, you can also do it mathematically. When you think about something being launched from the ground, delta y is 0 if you land back on the ground. So then I can go to the other equation, Viy times t plus 1/2 at squared, but that's all equal to 0. So 0 equals 50 times t plus 1/2. Now here's where you have to be careful. It's got to be negative 10 times t squared. Now here's a case where dropping the units makes it easier because then it looks like an Algebra 1 equation. So then I get 50t 1/2 minus 5t squared is equal to 0. Cancel out one of your t's. I get that t is equal to 10 seconds, which you already knew. Next thing is I want to go to delta x. Well, Vx is equal to delta x over t. So therefore, delta x is equal to Vx times t. So we have 10 seconds times 86.6 meters per second, 866 meters. That's pretty good. Now, to calculate time in the air, excuse me, not time in the air, for max delta y, we're going to use this same equation, except now delta y is equal to 50 times, well, how much time is it going to take to reach to the top? 5 seconds. You're only going to use half the time, plus 1/2 negative 10 times 5 squared. And that's solvable for you. You can do it. Okay, we'll talk more about this in class. Hope this